Hi students, let us start the three-phase AC system. So, what is actually meant by a three-phase system? See here, in an AC system, we do have two types. One is single phase AC and three-phase. 5 represents phase AC systems. In single phase, you have studied in the previous session that it is going to be having only one coil. That is, the case is this one. You are having a magnet, you are having a coil here, you are having a magnet here, north, south. This coil is going to be rotated, and you have studied that a sine wave will be produced in this pattern. This is the case with single phase. So, what do you understand from here? You will get that whenever one coil rotates in a magnetic field, it generates an EMF. It generates an EMF. Or one coil will produce one EMF. Or one coil will produce one voltage. So, what is actually meant by this three-phase system? 1-5 means single phase. 1-5 have one coil, so one voltage. So, what will be the case of three-phase? Three-phase will have, of course, three coils having three voltages. If it is having more than three, then it is known as polyphase system. Polyphase system. If it is having more than three phases, okay, then we will call it as polyphase system. Now, how I am going to represent these systems? See, I told you I am having three coils. So whenever I say I have three coils, I am going to name each coil. The first coil is known as red. I am going to call it as red R. Second coil is yellow. Since this yellow color is not visible to you, I am going to use this color, yellow Y. And third one is known as my blue D. Now, how should I keep these coils? See, we know that in a circle, the total angle is going to be 360 degree. So, I do have three coils. So, for balancing the system, I have 360 by 3, that is equal to 120 degree. Which means that in order to obtain a balance in our system, I need to keep the coils at an angle of 120 degree. So how it is going to be represented? Assume that I am having my first coil. So I do have, I'm going to draw the first coil. This is going to be my, if I assume here, this will be my x-axis representation. This will be my y-axis. Then I'm going to tell that my R is going to be kept along my x-axis, means 0 degree. Okay. Now, how do you realize a coil? So, whenever I told you that I'm having a coil, the coil is going to be represented in this pattern. So, there will be a starting portion, there will be a finishing portion. There will be a starting portion as well as finishing portion. So, I will tell that 0 agumbo, this is going to be start, this is going to be my finish. Now, I do have my second one. What is the color of the second? Second is going to be yellow. Since yellow is not working, I will be utilizing this another color. So where should I represent this yellow? It should be drawn at 120 degree. So this is 0, 1 to 90 means this one, 120 means somewhere in this plane I should represent. So I'm going to draw that. So what will be this one? This will be my start. This will be my finish. I do have my third coil. Third coil is represented in blue color. So I will have it as, this is going to be 0 degree. This is going to be 120. This is going to be 240. So 120 വെച്ചു. ഇനി ഇവിടുന്ന് ഞാൻ 240 measure ചെയ്യുന്നു somewhere from here. So if I draw that figure, this will be my third coil. This will be my start. This will be my finish. Okay, or I can tell the third coil will be connected at an angle of 120 from the second coil, that is yellow coil. Now I do have a magnet here. This will be my north. This will be my south. So I'm going to rotate it in this direction. Whenever I rotate, I will say that in each of this coil, red, yellow and blue, EMF will be induced. In all these three, an EMF will be, in all these three, an EMF will be induced. So I'm going to draw the nature of that waveforms that is going to be built up here. Now, look here. You can see the three colors being represented. See, I am going to draw an axis. Now, for the sake of simplicity, you do one thing. You mark the equidistant points like this. It should be equal. Now, you mark the points as 60. This will be 0. This will be 60. I'm taking 60. Why? Because I'm taking 60. Why? Because it is easy for me to represent the figures in a better way. So 0, 60. This is going to be 120. This is going to be 180, 240, 300. This is 360. 360 means whenever I think about a circle, 360 means when I start here and turn back to here means 360 is 0 itself. So I'm going to replace this 360 with 0. Again 60, 120, 180, 240, 300, 0, 60. Now I'm representing the maximum values as this one. For the time being, I'm going to assume that red is my first coil. So whenever my red coil is going to be rotated in a magnetic field, what will happen? You have studied that whenever a coil is rotated in a magnetic field, an EMF will be produced in the last session. That means in the basics of AC circuits. So if I start drawing, it will start from 0. It will be maximum at 90 degree and return back to 0 at 180, 270, 360. It is the case. So 90 means 60, 120. 60 day, 120 day, mid. That is, this is this point, 90. So here. So what did I understand? 1.5. Again 1.5. The 0.5 is 1. Appo anganeyana 1.5, 180. So here, then again 1.5, 270, 360, 90, 180. So I'm going to draw my sine wave. So I have represented my R. I have represented my R. Then second is yellow. Yellow coil is displaced from the first by an angle of 120 degree. This is going to be 0 degree. This is going to be 120. So 0, 120. So where will this waveform start? I told you it is displaced by 120 means the yellow color will start at 120. 1.5 will be maximum, again 1.50, again 1.5 negative maximum, again 1.50, again 1.5 maximum, again 1.50, again 1.5 negative maximum. So if I draw, so now in the similar way I can extend it in the backward direction. So if I continue, this is the case. Now where will be my third? Third one is going to be displaced from the first by an angle of 240 due to this concept 120 degree displacement. So 240. So my third waveform will start at 240, 1.5 max, 1.50, 1.5 negative max, 0, 1.5 positive max, 0. So if you continue, I can extend it backward also. I can extend it backward also. So this is what is going to be represented known as my three-phase waveform, where this represents red, this represents yellow, this represents blue. RYB. Then I am having a particular term there, sequencing. What is sequence? Sequence means how I represent these coils. See, I told you the coils are represented as red, yellow, blue. That is RYB. So one sequence it will be known as RYB sequence. Sometimes it is known as RYB. Or in the same pattern I can represent it as ABC sequence. ABC sequence. ABC sequence. R baikum, B kum pagaram ABC nu use. It is of sure that I will use the things in the same pattern is R, Y, B in a cyclic manner. So from R, Y, Y to B. We will not move from B to Y. It is a mistake. So we will assume always in the clockwise direction R, Y, B. Or I will write A, B, C again in a cyclic manner. In this session, I will be most commonly using this RYB sequencing for representing all the things. Now, I want to compare. I have completed how an AC is going to be generated. Okay, one more thing I will have to explain. I will write an equation. So look here. Say I do have my waveforms. For this red, I want to write an equation. For red, ER is equal to, if I assume this is a voltage wave, V, then this will be my Vm, this will be my negative Vm. So what will be the equation? It starts from 0, that is Vm sine omega t. What will be the equation for the second? Ey. Ey is equal to, again maximum height is Vm sine, it starts at, R starts at 0 degree, this one starts at 120. So what will be the difference? Omega t minus 120. And what will be the third one? Eb is equal to Vm sine, it reaches 0. This is a 0, but it is negative. For a sine wave, it should chart from 0 to positive. So I will take this point, sine omega t minus 240. So I have represented the equations for my sine wave also. I have represented the equation for sine wave also. Now we are moving on to the vector representation of a three-phase. So how will we represent the vectors? I told you that my sine wave, red is going to be connected at 0 degree. That is, my equation is ER is equal to Vm sine omega t, EY is equal to Vm sine omega t minus 120, and EB is equal to Vm sine omega t minus 240. If I represent it as a vector, ER is having an axis. Assume this is my x-axis, this is my y-axis. Now, if I draw Em sine omega t, means it is along my x-axis. This is my ER. I want to represent EY. EY will be at 120, means it will be displaced here. This will be my EY. This angle is going to be 120 degree. I want to draw my EB. EB will be at an angle of 240, means this will be my EB. This angle is going to be 240 degree, or what will be the angle between these two? This is going to be 120, and this is also going to be 120 degree. Okay, now I want to see how the things are going to happen in this case. Assume that I am having a single coil. Please wait for a minute. Assume that you are having a single coil. Okay, I'm going to represent it. If I keep a voltmeter across this one, it will measure me one voltage. Okay, so it measures voltage. So what is the voltage across a single coil? In case of a three-phase system, the voltage which is occurring across a single coil is known as phase voltage. Voltage coming across a single coil is known as phase voltage. And similarly, whenever I measure the current, I will say it is known as phase current. It is known as phase current. That is, the voltage and current measured here is known as phase voltage and phase current if it is having a single coil only. Now, we can see how this connections of this three-phase is going to take place. Whenever I move to a three-phase system, I can say it is having three-phase system is having two types. They are, first one, star, second is delta. It will be represented as star means Y, delta means normal triangle. So how you're going to differentiate? Look here, S, start alle, S alle, above I will say similar ends joined together. For this star connection, similar ends of the coil will be connected together. In this delta, then of course, dissimilar ends will be connected. So we will see in details how the star and delta is going to happen. So look here, first one, star connection. Star means it is going to be this Y connection. So I am having my first coil. First coil is of course red color. I'm going to draw it. This will be my start. This will be my finish. I will have my second yellow. Yellow it will be at an angle of 120. 120 എന്ന് പറഞ്ഞാൽ ഇവിടെ. What type of connection is this? Star means similar ends. This will be my F. This will be my start. And once again, I will have my blue at an angle of 120 from the second or 240 from the first. This will be my start and this will be my finish. You can interchange, no problem. This can be your start, this can be your finish. You can interchange, which doesn't create any problem. So how will be the connections? So I can take a connection out from here. I can take a connection out from here. I can take a connection out from here also. Okay, you look here, you are getting a common meeting point. It is known as N or neutral. This point is known as N or neutral. So I will have a connection in this pattern. We take a wire in this pattern. So how many wires are present here? I will say 1, 2, 3, 4. There are 4 wires present here for connection. Now, what will be the voltage measured here? If I connect a voltmeter across this one, what will be this voltage? If you observe, this is the same as this one. See, voltage across a single coil. This is also voltage across a single coil. So I can write it is known as phase voltage VPH. It is known as phase voltage. Similarly, I will write one more thing. This is going to be your R. This is going to be your Y. This is going to be your blue. Okay. Now, I believe you can see all these things. If I look here again, I will be having one more. This is also phase voltage. This is also a phase voltage. Now, look here. If I measure a voltage in this one, what is that? Here, I am measuring a voltage from between 2 coils. It is known as line voltage. It is known as line voltage. Which are lines? R and Y. There you will have to look into your sequence part. It will be R, Y, B in a cyclic manner. So, what will be this voltage? This is across R and Y. So, I can write V, R, Y. You should not write VYR because it is opposite. VYR is opposite. So, I am going to write VRY. Here also, I am having a voltage. This is also across Y and B, means 2 coils are present. This is going to be VL. This VL is going to be V, Y and B. So I can write V, Y, B, not BY. Then I have a third one between R and B. This is also a line voltage. It is equal to V, R and B. It is not RB, instead it is BR. It is VBR. I believe why you got VBR. VBR is nothing but minus of VRB, just negative. That's only the difference. VBR is nothing but minus of VRB. So, similarly, phase voltage. This is your N, I believe. So what will be this one? V between R and N. VRN. And then neutral LA. So we will eliminate it and we will write VR. What will be this one? Between Y and N? VY. What will be this one? Between B. This is between B and N. So VB. Now, I want to draw the vector for this one. That is the vector for this star connection. Now, look here. And we start. See, if I observe, this is R, I'm having VR, Vy, and Vb. VR, Vy, Vb. I'm going to represent that one. So if I draw, this is going to be my VR. I have shown you how to represent this waveforms in the previous case. VR, Vy, Vb. Instead of E, I'm going to write V. That's the difference. So ER, Vy, Vb. VR, Vy, Vb. Now, what is the first one? First one is Vry. So, right? So, what is Vry? Vry is equal to Vr minus Vy. So, I'm going to represent Vr is this one. First one is Vr. Vr is this one. Second one is minus Vy. Vy is this. Minus Vy means I should extend it backwards. Minus Vy. If I take the resultant, I will get Vry. Vry. Now, what is the second? Vyb. Vyb. What is Vyb? Vyb. Vy minus Vb. Vy ഉണ്ട് minus Vb എന്ന് പറഞ്ഞാൽ ഇതിനെ താഴോട്ട് നെഗറ്റീവ് ഡയറക്ഷനിൽ പോണം. Minus Vb. So if I take the resultant, I will get Vyb. Now, what is the third one? Third one is Vbr. Vbr. What is Vbr? Vb minus Vr. What is Vb minus Vr? Vb is this one. Vbr is Vb minus Vr. Vb is this one. Minus Vr means it should be extended in negative direction. Minus Vr. If I complete my parallelogram, this is going to be Vbr. Now, what will be this angle? 120. Then what will be this angle? It is going to be 60, and of course this angle is going to be 30 degree. I believe you got it. Now, since I took the vectorial way, I took it in a vectorial way, I can draw the vector equations. So observe for this part, Vry. So what will be Vry? Vry is equal to root of Vr squared plus Vy squared plus 2Vr Vy cos of angle is 60 degree, cos 60. Cos 60 is nothing but 1 by 2, that is root of Vr squared plus Vy squared plus Vr into Vy. What is Vr? Okay. Vr is nothing but Vph. Vy is nothing but V phase. Vb is nothing but Vph. So Vph is nothing but V phase. That is root of V phase squared plus V phase squared plus V phase squared, that is equal to root 3 V phase. What is Vry? Vry is nothing but VL. So I can write VL I can write VL is equal to root 3 V phase. VL is equal to root 3 V phase. Now, if you observe again, I have told you that what is meant by phase current. What is meant by phase current? Phase current means current flowing in a single coil. Look here. Look here. The current flowing in this one. What will be the current flowing in this one? This will be ഇതിലെ IR ഉണ്ട്, ഇവിടെ IY ഉണ്ട്, ഇവിടെ IB ഉണ്ട്. So if I measure the current here, ഇവിടെ ഒരു current ഞാൻ measure ചെയ്താൽ, if I measure the current here using an ammeter, then what will be the case? ഈ current ഇങ്ങനെ വന്ന് ഇതിലേ കയറി ഇങ്ങനെ ഇങ്ങ് പോവുക. ശരിയല്ലേ? ഇവിടുന്ന് ഒരു current തുടങ്ങി ഇതിലേ കയറി ഇതിലേ വന്ന് ഇങ്ങനെ കറങ്ങും. So that current is, what is that current? ഈ current തന്നെയല്ലേ ഇതിലേ വരുന്നത്. അപ്പോൾ IR. So whenever I measure between two coils, it is line value. I told you. Whenever I measure between a single, it is phase value. So you can see that this phase current is actually flowing in this line. So what can I say? In case of a star connected system, I phase is nothing but IL. In a star connected system, I phase is nothing but IL. So what are the points which we must keep in mind in case of a star connected system? The first point is this one. That is, for star, first point is we have derived VL is equal to root 3 V phase. VL is equal to root 3 V phase. നമ്മളിവിടെ derive ചെയ്ത് വെച്ചിട്ടുണ്ട്. കണ്ടോ? VL is equal to derivation എവിടെയാണ്? root 3 phase. VL is equal to root 3 V phase. Now, what is the second point? Second point is IL is equal to I phase. I have explained you just before. Now, what is the third point regarding power? How many types of power are present? There will be active, reactive, and apparent power. So first of all, I am going to look into active power. For a single phase system, AP ഞാൻ എഴുതാണ്, active power AP എഴുതിയ, active power is equal to VI cos phi. Okay, അപ്പോൾ മക്കൾ ഇവിടെ നോക്കിക്കേ, ഇതല്ലേ ഒരു സിംഗിൾ ഫേസ് എന്ന് പറയുന്നത്. അതിന് ഞാൻ എന്താ പറയുന്നത്? ഫേസ് എന്നാ വിളിക്കുന്നത്. ശരിയല്ലേ? അപ്പോൾ V ഫേസ് കൊണ്ട് I phase ഒരു കോയിലിനെ കുറിച്ച് ഞാൻ പറയാം. മക്കളെ, ഇതിനകത്ത് if I take the connection in this one, ഇത് കണ്ടോ, ഈ ആറിനും എന്നിനും അക്രോസ് എടുത്താൽ it is a single phase supply. Similarly, Yക്കും എന്നിനും അക്രോസ് എടുത്താൽ it is again another single phase supply. So instead of this V, I can replace it with V phase. Iക്ക് I phase. അപ്പോൾ ത്രീ ഫേസിന്റെ കേസിൽ എങ്ങനെയായിരിക്കും മക്കളെ? ത്രീ ഫേസ് ആക്റ്റീവ് പവർ ഇസ് ഈക്വൽ ടു, ഒരു കോയിലും കൊണ്ട് ഇത്രയും കിട്ടും. അങ്ങനെയാണെങ്കിൽ മൂന്ന് കോയിലും കൊണ്ട് എത്ര കിട്ടും? 3 into V phase into I phase into cos phi. But we have seen what is the relationship between VL is equal to root 3 V phase എന്ന് പറഞ്ഞാൽ what is V phase? V phase is equal to VL by root 3. So I can write this active power is equal to, power P is equal to 3 into VL by root 3 into IL into cos phi. I phase is nothing but IL. So I'm going to replace I phase with IL. So this one, that is equal to root 3 VL IL cos phi. So what is the equation for active power? Three-phase active power is equal to 3 V phase I phase cos phi or root 3 VL IL cos phi. Very, very important. Now, what is the case with reactive power? Second one, reactive power. What is the case with reactive power? What is reactive power? For a single phase system, reactive power is VI sin phi. VQ I ക്കും പകരം V phase I phase sin phi എന്ന് എഴുതാം. അങ്ങനെയാണെങ്കിൽ ത്രീ ഫേസിന് എത്രയായിരിക്കും? ത്രീ ഫേസ് reactive power is equal to 3 into V phase into I phase into sin phi. I can replace V phase with root VL by root 3. That is equal to 3 VL by root 3. As per the previous case, I phase is IL into sin phi. So I will get that is equal to root 3 VL IL sin phi or reactive power. Three-phase reactive power is equal to I'm having two equations, 3 V phase I phase sin phi or root 3 VL IL sin phi. Root 3 VL IL sin phi. Now, what's the third power? Third part is apparent power. Third one is apparent power. For single phase, apparent power is equal to VI. That is V phase into I phase. For a three phase, it is equal to 3 V phase I phase. V phase is nothing but VL by root 3 and I phase is IL. So I will get 3 VL by root 3 into IL. That is equal to root 3 VL IL. So apparent power for three phase is equal to, I'm having two equations, 3 V phase I phase or root 3 VL IL. With this one, I'm finding out my star connection. Similarly, the second part is going to be, second one is delta connection. So I do have my first coil. American service on. What is delta? Dissimilar ends. Connected. Dissimilar ends connected. So I'm going to represent my first coil. This is going to be my start. This is going to be my finish. Yellow. Okay. This is going to be my start. This is going to be my finish. I have the third one. This is going to be my start. This is going to be my finish. So if you observe here, start and finish, start and finish, start and finish means dissimilar ends are going to be joined together. I have three meeting points. So what is the main difference? In the previous case of a star, I had this common meeting point, it is known as neutral, but here I don't have a common meeting point. So I will call it as there will be no neutral in this one. So what will, listen me very well, what will be the voltage coming across this one, a single coil? It is known as my phase voltage. So what will be the voltage coming here? ഇതെന്ന് പറഞ്ഞാൽ ഇത് തന്നെ. So what is this? If I measure this voltage, it is actually your line voltage, but if I look in a deep manner, I can say it is a voltage I experience here. So it is nothing but phase itself. Okay. Now, if you observe regarding the current, here I will have a current starting about IR, IY, IB. If you observe at this point, IR is coming, IB is going, so I will have a resultant current here. Okay, IR is coming, IB is going, so there will be a current. So what is the case here? Here I will have a current. If I assume R, Y, B, I will be having a current in this one, that is IRY. This is IYB. There will be a current here. It is known as IBR. I have explained the reason why we are telling IBR instead of RB. Now, if I represent that currents in a vectorial, voltages are same, so I don't need to represent. I want to represent the current. Here I will have my IR. Here I will have my IY. Here I will have my IB. What is the first one? First one is IRY. What is IRY? IR minus IY. So minus IY is this one. If I complete the parallelogram, what I will get is known as IRY. Second one is IYB. IYB is IY minus IB. So IY is here, IB is here. So I can represent minus IB. If I represent complete the parallelogram, I will get IYB, and the last one is IBR. IB minus IR. This is minus IR. If I complete the parallelogram, I will get IBR. This angle is 120. So this angle is going to be 60, and this angle is going to be 30 degree. So if I continue with my representation, that means the voltage part, I can write it in this way. That is IRY is equal to root of IRY is this one, this part. IRY is equal to root of IR squared plus IY squared plus 2IR IY cos 60. IR is nothing but I phase squared, I phase squared plus 2 and 60. Cos 60 is 1 by 2, 2 and is cancelled. So again I phase squared, you will get root 3 I phase. That is IRY is nothing but IL. IL is equal to root 3 I phase. IL is equal to root 3 I phase. So what are the points you should remember here? In this case, for a delta connection, first point is VL is equal to V phase. Second, IL is equal to root 3 I phase. IL is equal to root 3 I phase. Third part is power. Power is 3 parts: active, reactive, apparent. So what is active power? Similar to the previous case, that is for a star, 3 V phase, I phase, cos phi. So I will write 3 into V phase is nothing but VL, 3 VL, I phase is IL by root 3 into cos phi, that is equal to root 3 VL, IL cos phi. So the expression for active power is of two types, 3 V phase, I phase, cos phi or root 3 VLIL cos phi. Reactive power, similarly you can calculate, that is 3 V phase, I phase, sin phi or root 3 VL IL sin phi, and apparent power is equal to, we can observe the previous case of a star, 3 V phase, I phase or root 3 VL IL. Equations are same. The only difference is for a delta, VL is equal to V phase and IL is equal to root 3 I phase, and for a star, VL is equal to root 3 V phase and IL is equal to I phase for star connection. Thank you.